So this last video for 3.3 is what every textbook tries to do for every single chapter. It's try to apply what you've learned. So we are going to take these skills that we've learned of, maybe finding the zeros of a quadratic function, maybe finding the solutions of a quadratic equation, maybe finding the max or the min, something along that area in a word problem. So this is an application of quadratic equations, and it is a geometry or an area or a perimeter one. So what have we got? Well, we got 40 meters of fencing to enclose a rectangular pen. If you've taken enough math classes with us, these start getting really boring. So if you have 40 meters of fencing to enclose a rectangular pen, that means that you have 40 meters to go around the perimeter of the fence. Okay, we know that perimeter is 2L, so 2 lengths plus 2 widths. Okay, what else? We want to represent the area of the pen as a function of the length of one side of the pen. That feels familiar from chapter 1. So what are we going to do with that? Well, we want to maximize area. So area is length times width. But I can't have an equation that has 3 variables, right? I can have an equation that has 2 variables. So I want to represent area as a function of the length of one side. Now, when it says the length of one side, it doesn't mean it wants the length. It's like width is a length as well. And it doesn't matter which one's length and which one's width. But we can't have both. So what I'm going to do is I'm going to put the 40 in for perimeter. And then I'm going to isolate either the W or the L. So let's go L. Okay, so 2 L's is equal to 40 minus 2 W's. And then I divide both sides by 2, and I get 20 minus W equals L. So now I have the length in terms of the width. So I'm going to replace my L with 20 minus W times W. And now I have area as a function of width, which is the length of one of the sides, right? Even though it's a width, it's still a length. Okay, so now what do? Well, it wants to know the max. Maximum is the vertex. So how do we do that? Well, the vertex, we have a couple ways to finding it. First thing I'm going to do is simplify. I'm going to multiply the W through, so I get 20W minus W squared, and then I'm going to write it in descending orders of power. So negative W squared plus 20W. Now, again, a question can ask you, what are the zeros? I guess for this one it would be, what could they ask you? What width or what dimensions could give you an area of 0? That'd be kind of a silly question. But they could specify like what width would give you an area of 40 or something like that. But really these questions are usually about max. So we need to find the max, we need to find the vertex. We have 2 methods. You can use the formula, negative b over 2a, or you can complete the square. Now I know you guys are perfectly capable of plugging into a formula, so I'm going to demonstrate completing the square. So I'm going to greatest common factor out that -1 to be left with W squared minus 20W. Then I'm going to complete the square by taking half the middle term, which is 10. I'm going to square it, and I'm going to add it, and I'm going to subtract it. And then I'm going to take the negative out, so W squared minus 20W plus 100, -1 times -100. And I end up with negative W minus 10 squared plus 100. So that tells me that my vertex, which is going to be my max, because this graph is opening down, and don't worry about that, it'll always happen right for you. My vertex is 10 and 100. Well, what does that mean? Well, if we think about the graph, the vertex is happening at 10 and 100. So let's just put it here. What do those values mean? Like, what is x? Well, x is the width because it's area as a function of the width. In other words, this 10 is the width that gives you a maximum area of 100. So the y value in this one is your area, and the x value is your width. So now let's answer the questions. It says, what dimensions give you the maximum area, and what is the maximum area? So therefore, the dimensions are, so we've got a width of 10. So the length would be 20 minus 10. So the dimensions are 10 by 10. And the max area is 100. meters squared. And that's it. All right, let's look at another one. So a stonemason has enough stones to enclose a rectangular patio with a 60-foot wall. Seeming familiar. But this time, the house forms one side of the rectangle. What is the maximum area that a mason can enclose, and what should the dimensions of the patio be in order to yield this area? So the biggest difference here is that we have a house on one side. So our stone fence only has to go, or wall, only has to go on 3 sides. So pause the video, see if you could come up with the equation of area as a function of one of the dimensions, so length or width, and then once you know you're good, then you could keep going. So hopefully you did. Pause the video. So this time we know that the perimeter is 60, but the perimeter is only covering. So let's say that this is width, and this is length. And it wouldn't matter if you had them switched, right? Because the answer just says dimensions. It's not very specific. So I'm going to say that my perimeter for this guy is length and 2 widths. So I'm going to put in that the perimeter is 60. So 60 equals L plus 2W. So the way I have this written out, I'm going to solve for L again. I get L equals 60 minus 2W. So now I've got length in terms of width. So now I can write my area equation. Area, it's still a rectangular pen, so it's still length times width. But this time, well actually again, I'm going to replace the length with 60 minus 2L. Not 2L, sorry, 2W. Times W. So now I have area as a function of width again. Okay, and then I just keep going. So now if you feel okay from there, now you're going to simplify, and then you're going to find the vertex. So I'm going to multiply the W through. I get 60W minus 2W squared. I get negative 2W squared plus 60W. And this is what I'm going to use to find the max. So the max, again, I'm finding the vertex. To find the vertex, I'm going to again do it by completing the square. More than welcome, you guys. You can do negative b over 2a. Okay, w equals negative b over 2a. But sometimes I feel like the more times you see completing the square, the better. Eventually, it just seems like, oh, that's really all it is. So I'm going to greatest common factor out of negative 2. I'm left with w squared minus 30w. And then I'm going to take half the middle term, which is 15, and I'm going to square it. Now I'm pretty sure it's 225, but I feel like I'm making mistakes today. So squared. Yeah, okay, so I'm going to add 225. Now this time, instead of writing the minus in the bracket, I'm going to take it out here. I'm going to say, hey, that minus 2 is going to get multiplied by minus 225. Just save myself a step. Then I'm going to factor. So this would be w minus 15 all squared plus 450. Now what? Well, that tells me that my vertex is 15, 450. It is a max because there's a negative out front. And again, like I said, that will always be taken care of in your equation. And what does that mean for this example? Well, again, it's area as a function of width. So when the width is 15, I get a max area of 450. So let's answer it. Therefore, the max area is 450 square feet when the dimensions are 15 by, now when the width is 15, what is the length? So length would be 60 minus 2 times 15. So that would make it 30. So when the dimensions are 15 by 30. And these questions will get very repetitive. There's only so many ways that they can ask them. And we did these ones in Math 50 as well, if you recognize them. Last application. So these ones are kind of my favorites because instead of them trying to come up with this obscure way of coming up and getting you guys to come up with an equation, they just give you the equation. They're like, hey, you know what? Here's an equation. It's a quadratic function. Okay, so it's not an equation, it's a function. This is what is a function of what? Well, it's the effectiveness of a television commercial depends on, so is a function of, how many times a viewer watches it. So E is the effectiveness of a commercial based on N, which is the number of times it's viewed. And it's given by the equation, effectiveness is a function of the number of times viewed equals 2/3 n minus 1/90th n squared. How many times, so how many times must a viewer watch a commercial for max effectiveness? Vertex. So all these application questions have been Vertex questions. I mean, they're in section 3.3, right? So here we go. First thing I'm going to do is write it in descending orders of power. So I'm going to put -1/90th n squared plus 2/3 n. And now I need to find the vertex. Now here's one where you might convince me not to complete the square. And the reason why, I mean, it's fractions and they're kind of really gross fractions. And the other reason is they don't ask you what is the effectiveness. They just want to know n. They only want to know the x value of the vertex. So the x value of the vertex, n, is going to equal -b/2a. I'm going to use the formula. So -b would be -2/3 over 2a, which would be 2 times -1/90th. Okay, let's see how we can simplify this. Well, we've got -2/3 divided by 2 over 1 times 1 over 90 is -1 over 45. Right? Simplify the 2 and the 90. And then I'm going to rewrite that. I'm going to rewrite this as -2/3 divided by -1 over 45. Flip and multiply, so I get -2/3 times. Now I always keep the negative in the numerator. So -1 over 45 is the same as -45 over 1. And then I can multiply across, or I could simplify first, depending on what you're comfortable with. I'm going to simplify first. So 3 goes into itself once and into -45, -15 times. And then I'm going to multiply across. So -2 times -15 is +30, and then 1 times 1 is 1. So therefore, a viewer must watch 30 times for max effectiveness. Whew. All right, so that's it. So you are going to do applications of vertex, so of finding a max or a min. Sometimes you're responsible for coming up with the equation, sometimes they give you the equation. But solving it is just always finding the vertex, which you can do by completing the square or using the vertex formula.